Alright, this is a review of the radicals quiz. 8 questions, simplifying radicals. Let's start with question number 1. Question number 1. There we go. Question number 1 was 5 root 30. 5 root 30. I want to find all the factors of 30, and preferably I'd like to find perfect squares. Well, it's going to be what? 30, 1, 15, 2, 10, 3, nothing for 4, and 6, and 5. So I'm looking at these, and I want to find a perfect square that's a factor of any of these, and I am not finding any perfect squares in here. 15, of course, has factors, but one of them is 5 and the other one is 3. 10 has factors, and that's 5 and a 2. No, there are no perfect squares that I can pull out of 30. And so the answer to question 1 is that we leave it the way it is. It is in its simplest form. The exact answer is 5 root 30. Question number 2. Question number 2, 3 root 20. 20. I break 20 down into factors, and the obvious ones that jump out are 4 times 5. Now, square root of 4 is 2. That moves the 4 to the outside, but it turns into a 2. So it's going to be 2 times 3 times root 5. So the 4 moved out and became a 2. And 2 times 3 is 6. Final answer is 6 root 5. Question number 3 is 3 root 125. This is question number 3. 3 root 125. Is there a perfect square that is a factor of 125? There is. 3 root 25 times 5. Square root of 25 is 5. That means we move a 5 to the outside. 3 times 5. We leave the other 5 inside. That's as far as it will go. 3 times 5 is 15. My final answer is 15 root 5. Question number 4. Question number 4 is 4 root 32. Alright, so I'm looking for a perfect square that is a factor of 32. Well, 4 goes into 32 8 times, but even better than that, and there's nothing wrong with doing that. Let's try that first. 4, 8 times 4. Now, we know the square root of 4 is 2. We move the 2 to the outside. That's 2 times 4 root 8. But wait, 8 still can be factored, so let's multiply these together. We get 8 on the outside, but remember 8 is 4 root 4 times 2. And again, I have the square root of 4 on the inside. It can move to the outside, turns into a 2, becomes 2 times 8 root 2, or 16 root 2. But there's another way I could have done this one, and what I could say to myself is, alright, wait, 4 root 32 is simply 4 16 times 2. Square root of 16 is 4. I get to move that to the outside. I get 4 times 4 root 2. 4 times 4 is 16. 16 root 2. Different path to the same answer. Question number 4. Question number 5. Question number 5. Now this question involved rationalizing the denominator. In the numerator we had 4 root 2. In the denominator we had root 5. So it's 4 root 2 over root 5. I don't like having the root 5 in the denominator, and neither does the EOC. We call this rationalizing the denominator. We're getting that radical out of the denominator, and what we're going to do is we're going to multiply by the equivalent of 1. And square root of 5 over the square root of 5 is the same as multiplying by 1, which means we haven't changed the value of this at all. We've just multiplied it by 1. But it's this form of 1. So we multiply it through. Root 5 times root 5 equals 5. And then 4 root 2 times root 5 is 4. And that's going to be root 10. And so we have 4 root 10 over 5. 10 just has factors of 10 and 1, 5 and 2. And they cannot be any more exact than that. And so my final answer is 4 root 10 over 5. We have another rationalizing the denominator question, and that would be question 6. Question 6, root 2 over 2 root 3. Now, there's nothing wrong with this 2 in the denominator, but I want to get rid of the radical 3 in the denominator. So I'm going to multiply by radical 3 over radical 3. All I'm doing is multiplying by 1. I don't change the value of this. I'm just going to change the way it's written out. So if I multiply the top, I'm going to get root 6, it's 2 times 3, and then in the denominator, I'm going to get 2 times 3, right? Root 3 times root 3 is 3. And so I'm going to get root 6 over 6. Wait a minute, can I divide these two? I can't. The square root of 6 is some number between 2 and 3. I don't know what it is, but say it's 2.2. If it's 2.2 over 6, yeah, I could play some games with that, but there's no relationship between this 6 and this 6 because this 6 is inside the square root sign. This is your final answer for number 6. Number 7 was a solving question. Number 7. 10 equals square root of v over 5. So I look at this. In algebra, I always want to get the variable by itself. I want to get v by itself. I don't want it to be divided by 5. I don't want to have the square root taken of it. So I have to work my way into that v. Here we go. 10 equals the square root of v. What I'm going to do is, and I've missed because that email appeared, I sort of lost my rhythm for a second. How do we get rid of this? What we're going to do is we're going to square this. Now if I square this side, that will get rid of my square root, because the square root times the square root simply becomes whatever is under the square root sign. And that means I have to do the same thing to the other side. I need to square both sides. 10 squared is 100. And then what happens, as I said, when I square this, is it becomes 100 v over 5. Basically, the 2 and the root sign cancel each other out. Alright, so I've got a v now. What's happening to the v? It's being divided by 5. How do I undo division? I undo division by multiplying. So I'm going to multiply both sides by 5. I get 500 equals v. There we go. Question number 7. And then my last question, question number 8. Again, an equation. 54 equals 9 root 6. Okay. What's happening here? 9 root k. I'm sorry. It's 9 root k. I want to get the k by itself. What's happening to the k? Well, it's being, the square root of k is being multiplied by 9, so I'm going to undo using division. 6 equals square root of k, and then I'm just going to square both sides. Squared 36 equals k. And that is my final answer.